Hello everyone, I'm Manasa Narukuda. I'm going to describe about query optimization. Today we learn what is query optimization and what are the techniques we have to use in the query optimization, advantages of query optimization and all those. So let's go into the topic query optimization. So usually what is query optimization? So to execute a query in an optimized way is about the query optimization. Is nothing but basically to execute a query in minimum time. And we can also say is the overall process of choosing the most effective means of executing a SQL statement. That means we minimize the use of certain resources like input output time and CPU time by selecting a best execution plan. So this is the query optimization. Next, going to the purpose of SQL query optimization. So there is a purpose of SQL query optimization. Those are reduced response time, reduced CPU execution time, improved throughput. So reduced response time. Here our major goal is to enhance the performance by reducing the response time. And coming to the reduced CPU execution time, we can obtain the faster results if we reduce the CPU execution time and the improved throughput. The number of resources to be accessed to fetch all necessary data should be minimized here. The number of rows to be fetched in a particularly core should be in the most efficient manner such that the least number of resources are used here. So these are the purpose of SQL query optimization. Then going to the SQL query optimization techniques. So there are techniques for SQL query optimization. So here optimization is an iterative process. One must compose the query, evaluate its performance with the use of statistics or an execution plan, and then optimize it. So this cycle must be repeated iteratively in order to optimize the queries. The SQL Server also determines the best and minimal query execution plan. So going into the query optimization techniques, let's see indexing. Indexing is one of the query optimization technique. So an index is a data structure used to provide the quick access to the table based on a search key. So how it helps? It minimizes the disk access to fetch the rows from the database. An indexing operation can be scan or a seek. An index scan is a traversing entire index for matching criteria, whereas index seek is filtering rows on a matching filter. So this is what the indexing does. Here we can see the example in the figure. It shows the percentage wise. In the above query here, we can see the total of 99% of the query execution time goes in index seek operation. So this is what means we understand how it's an important part of the optimization process. So next going to the guidelines for choosing the index. When we are choosing an index, we have to follow some guidelines. So those guidelines are index should be made on keys that frequently occur in where class and join statements. This is what means when we are choosing an index on keys that frequently occur in where class and join class. And the indexes should not be made on columns that are frequently modified. Update command is applied on these columns frequently. And the third point, indexes should be made on foreign keys where insert, update, delete are concurrently performed. This allows updates on the master table without shared locking on the weak entity. So, coming to the fourth point, indexes should be made on attributes that occur togetherly commonly in where class and operator. Finally, we have to follow the guideline that index should be made on ordering the key values. So, these are the guidelines we have to follow when choosing an index. So, and the another technique is selection. So, what is selection? Selection of the rows that are required instead of the selecting all the rows should be followed. Select is highly inefficient as it scans the entire database. So we can see from the two outputs. Here the time is reduced to 1/4 when we use the select statement for selecting for those columns that are required. So we can understand it reduces the time when we use the select statement. This is the selection technique. And going to the avoid using selection distinct. Here, this command is used for fetching unique results and remove duplicate rows in this relation. To achieve the task, it basically groups related rows and then removes them. Here in the two figures, we can see the execution of the two queries. The distinct operation takes more time to fetch the unique row. So it is better to add more attributes in the select query to improve the performance and get unique rows. So this is the avoid using select distinction. Then coming to the line limit command. The limit command is used to control the number of rows to be displayed from the result set. That means we can see here all the displays here. It controls the number of rows to be displayed from the result set. The result set needs to display only those rows are required. Therefore, one must use the limit with the production data set and provide an demand computation of rows for production purpose. So, in the figure we can see the above query prints the top 10 rows of the result set. This drastically improves the performance of the query. This limit command improves the performance of the query. So here, going to the methods which make the SQL query faster, we have to follow those methods to make it faster. Those are, we have to avoid the fetching all results when it is necessary. Instead of that, we can specify which columns you want and explore the limit number of results. So next, coming to the another method, we have to apply where in the select statement to target only a part of data you need. And then we have to check the indexes thoroughly, and we have to add missing the indexes. We have to identify the unused indexes, and we have to fix the broken indexes. A decent SQL index manager can be the great help in this aspect. So, and another thing we have to keep in the mind is we have to avoid too many joins. In this case, if we require the join, in this case, we have to apply the inner joins and avoid using group by and heavy classes if it is not necessary in your case. And then last one is large queries must be executed during the off-peak hours. While we are performing, these are the well-known methods to make faster. Next, going to the advantages of query optimization. There are few advantages like lesser stress on the database, less memory is consumed, faster processing of query, lesser cost per query, high performance of the system, efficient usage of database engine. These are some pros of query optimization. The next, going to the conclusion, we have to avoid the correlated nested queries. And then we have to avoid inner joins with quality or out conditions. And we have to use the wildcards wisely. Use indexing properly to create more indexes for fetching composite columns. And we have to try to use where rather than having. Only use having for aggregated values. So these are the minor changes in queries can improve the performance of the queries drastically. And they will help to boost performance of application, providing a better user experience. Thank you.